Everyone, welcome back to the online classes. Dear students, in this class I am going to explain the gas laws. In the last class we have discussed about the introduction concept of kinetic theory of gases and behavior of kinetic theory of gases and real gas, ideal gas, the difference between real and ideal gas. In this class I am going to explain the gas laws. Gas laws. These are the very important laws in this topic. The first law is, or here, the behavior of kinetic theory of gases. Behavior of gases or behavior of kinetic theory of gases can be described in terms of macroscopic variables. Macro means very large, like pressure, volume, and temperature with the help of gas laws. With the help of gas laws. It is very important concept in this topic. First law is that is called Boyle's law. That is called Boyle's law, and the second one is Charles law, and the third one is Gay-Lussac's law, and the fourth one is Dalton's law of partial pressures, or this is also called Avogadro law. Now we will see one by one. Boyle's law here. Suppose if you consider any one a given mass in a container, for a given mass of gas at a constant temperature, the pressure of the gas is varies inversely with the volume. Boyle's law, it states that at a constant temperature, the pressure of the gas is varies inversely with the volume. It is very simple statement. At a constant temperature, the temperature is kept constant. At a constant temperature, the pressure is inversely proportional to the volume. Then it is called Boyle's law. Yeah, the temperature is kept constant at a constant temperature for a given mass of a gas. ನಾವು ಯಾವುದನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ ಅದಕ್ಕೆ. For a given mass of a gas at a constant temperature, the pressure of the gas is varies inversely proportional with its volume. The pressure is inversely proportional to its volume at a constant temperature for a given mass, then it is called Boyle's law. Mathematically, it expressed as P is inversely proportional to the volume, or PV is equal to constant. Constant, ಯಾವ್ದು ಕಾನ್ಸ್ಟೆಂಟ್ ಇರ್ತವೆ ಅಲ್ಲಿ temperature is kept constant. Boyle's law, it states that for a given mass of a gas at a constant temperature, the pressure of the gas it varies inversely with the volume. The pressure of the gas is varies inversely with the volume with a constant temperature, then it is called Boyle's law. And here, observe this phenomena. Here, the temperature is kept constant. The temperature is kept constant. Observe this diagram. Here in this diagram, the temperature is 300 degrees Celsius. The temperature is 300 degrees Celsius, and in the left hand side of the scale, here, observe this scale and this scale. These are the two scales. This is the left hand and this is right hand side. Here in this, the left hand side of the scale, this is pressure and this is temperature. This is measured by with degree Celsius. This is the temperature scale and this is pressure scale. When the heat is supplied to this system, this is the one system. Here for a given mass, the temperature is kept constant. The temperature is kept constant like 300 degrees Celsius. Like 300 degree Celsius. When the temperature is kept constant like 300 degrees Celsius, the pressure is increases, the volume is decreases. The pressure is increases, volume is decreases. Observe this phenomenon. This is the beautiful phenomenon. Pressure increase ಆಕೋತ ಹೋಯಿತು ಅಂದ್ರೆ ಮೊದಲು ನೋಡ್ರಿ ಪ್ರೆಷರ್ 1 ಕ್ಕೆ ಇರತ್ತ, 1 ಇಂದ 2 ಕ್ಕೆ ಇನ್ಕ್ರೀಸ್ ಆಕೋತ ಹೋಯಿತು ಅಂದ್ರೆ ವಾಲ್ಯೂಮ್ ಡಿಕ್ರೀಸ್ ಆಕೋತ ಬರುತ್ತೆ. ವಾಪಸ್ಸು ಪ್ರೆಷರ್ ಡಿಕ್ರೀಸ್ ಆಕೋತ ಬಂದಾಗ ವಾಲ್ಯೂಮ್ ಏನಾಗುತ್ತೆ, ಇನ್ಕ್ರೀಸ್. The variation of volume with respect to pressure or pressure with respect to volume is shown in this graph. ಈ ಫೆನಾಮೆನಾವನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರಿ ಅಂದ್ರೆ easily we get the Boyle's law. For a given mass of a gas at a constant temperature, for a given mass of a gas at a constant temperature, the pressure of the gas it is varies inversely with volume. P is inversely proportional to volume. Here, when the heat is supplied to the given system for a given mass at a constant temperature. ಈ ಎರಡು ಸ್ಕೇಲ್ ಅದ, ಒಂದು ಪ್ರೆಷರ್ನ ಮೆಜರ್ ಮಾಡ್ತಕ್ಕಂಥ ಸ್ಕೇಲು, ಇನ್ನೊಂದು ಟೆಂಪ್ರೇಚರ್. And what conditions? Under the constant temperature. Under the constant temperature, yeah, the pressure is inversely proportional to its volume, or the volume is inversely proportional to its pressure. Pressure 1 ಇಂದ 2 ಹೊಂಟಿತ್ತು ಅಂತಂದ್ರೆ ಅವಾಗ ವಾಲ್ಯೂಮ್ ಏನಾಗತ್ತಿರತ್ತೆ, ಡಿಕ್ರೀಸ್ ಆಗ್ತಿರುತ್ತೆ. ಗ್ರಾಫ್ ನೋಡ್ರಿ. ಬಟ್ 2 ದಿಂದ 1ಕ್ಕೆ ರಿವರ್ಸ್ ಬರಬೇಕಾದ್ರೆ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಅಗೇನ್ ಇಟ್ ಈಸ್ ರಿವರ್ಸ್. ಇಟ್ ಈಸ್ ಎ ರಿವರ್ಸ್ ಪ್ರೊಸೆಸ್. It is inversely proportional. This is called Boyle's law. It states that for a given mass of a gas constant at temperature, the pressure of the gas is varies inversely with its volume. This is about Boyle's law. And the next one is, that is Charles' law. In this law, it states that for a given mass of a gas at a constant pressure, here the pressure is kept constant, the volume of the gas is directly proportional to its absolute temperature, or its temperature. For a given mass of a gas at a constant temperature, pressure is inversely proportional to volume. That is called Boyle's law. But Charles' law, it states that for a given mass of a gas at a constant pressure, the volume of a gas is directly proportional to its absolute temperature. For a given mass of a gas at a constant pressure, the volume of a gas is directly proportional to its absolute temperature. The volume of the gas is directly proportional to its absolute temperature. At a constant pressure, the pressure is kept constant. The pressure is kept constant. Volume is directly proportional to temperature. Volume is directly proportional to temperature, or P divided by T is equal to constant antu kuda helbodu ನಾವು. Charles' law, it states that for a given mass of gas at a constant pressure, the volume of the gas is directly proportional to its absolute temperature. If the volume of the system is increases, the temperature of the system is also increases. If the volume of the system is decreases, the temperature of the system is also decreases. This is called Charles' law. At a constant pressure, the volume of the gas is directly proportional to temperature. Observe this phenomena. When the heat is supplied to the system, both at a constant pressure, again ಇಲ್ಲಿ ಎರಡು ಸ್ಕೇಲ್ ಅದಾವ. Pressure is a constant 1.5 ಇದೆ. What is the SI unit of pressure? Pascal. 1.5 Pascal ಇದೆ pressure. The pressure is kept constant, but the volume and the temperature, both the phenomena are increases. ವಾಲ್ಯೂಮ್ ಟೆಂಪ್ರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಆಯಿತು ಅಂದ್ರೆ ವಾಲ್ಯೂಮ್ ಕೂಡ ನೋಡಲಿ ಏನಾಗ್ತದೆ, ಇನ್ಕ್ರೀಸ್. ದ ವರ್ಕ್ ಡನ್, ಹೌದಾ, ದ ಅಮೌಂಟ್ ಆಫ್ ವರ್ಕ್ ಡನ್ ಟು ಬ್ರಿಂಗ್ ದ ವಾಲ್ಯೂಮ್ ಫ್ರಾಮ್ 3 ಮೀಟರ್ ಕ್ಯೂಬ್ ಟು 5 ಮೀಟರ್ ಕ್ಯೂಬ್. ಕರೆಕ್ಟಾಗಿ ನೀವು ಡೈಗ್ರಾಮನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರಿ ಅಂತಂದ್ರೆ, ಅಲ್ಲಿರುವಂತಹ ಡೈಗ್ರಾಮನ್ನು ನೀವು ಕರೆಕ್ಟಾಗಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರಿ ಅಂತಂದ್ರೆ ಎಲ್ಲಿಂದ ಎಲ್ಲಿವರೆಗೆ ಹೋಗ್ತಾ ಇದೆ ನೋಡ್ರಿ, ಅದು ವಾಲ್ಯೂಮು. ದ ವಾಲ್ಯೂಮ್ ಈಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಟೆಂಪ್ರೇಚರ್. ಇದನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡಿ. 3 ದಿಂದ 5 ವರೆಗೆ ಹೋಗುತ್ತೆ. ಯಾವಾಗ ಹೋಗುತ್ತೆ 3 ರಿಂದ 5ಗೆ? And the certain amount of heat is supplied to the given mass at a constant pressure, the volume is directly proportional to temperature. That the temperature is increases, the volume of the gas is also increases. This process is shown in this graph. ಇಲ್ಲಿರ್ತಕ್ಕಂಥ ರೈಟ್ ಸೈಡಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಗ್ರಾಫಲ್ಲಿ the volume is increases, the temperature is also increases. ಇಲ್ಲಿ ನೋಡಿ, if the volume is increases, temperature is also increases. ವಾಲ್ಯೂಮ್ ಡಿಕ್ರೀಸ್ ಆದಾಗ ಟೆಂಪ್ರೇಚರ್ ಕೂಡ ಏನಾಗುತ್ತೆ, ಡಿಕ್ರೀಸ್. ಎರಡು ಫೆನಾಮಿನಾವನ್ನು ನೀವು ಈ ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಬಹುದು. ದ ವಾಲ್ಯೂಮ್ ಈಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಟೆಂಪ್ರೇಚರ್. ವಾಲ್ಯೂಮ್ ಜಾಸ್ತಿ ಆಯಿತು ಅಂದರೆ ಟೆಂಪ್ರೇಚರ್ ಕೂಡ ಏನಾಗ್ತದೆ, ಜಾಸ್ತಿ ಆಗ್ತದೆ. ಟೆಂಪ್ರೇಚರ್ ಕಡಿಮೆ ಆಯಿತು ಅಂದರೆ ವಾಲ್ಯೂಮ್ ಏನಾಗುತ್ತೆ, ಕಡಿಮೆ ಆಗುತ್ತೆ. ದೇ ಆರ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಈಚ್ ಅದರ್ ಅಟ್ ಅ ಕಾನ್ಸ್ಟಂಟ್ pressure. This is about Charles' law. And the third law, that is called Gay-Lussac's law. Here, for a given mass of a gas at a constant volume, for a given mass of a gas at a constant volume, the pressure is directly proportional to absolute temperature. For a given mass of a gas at a constant volume, there is no change in the volume. The pressure is directly proportional to the temperature. Pressure is directly proportional to the temperature. And best example for this law is ನಿಮ್ಮ ವೆಹಿಕಲ್ಗೆ ನೀವು ಏರನ್ನು ಹಾಕ್ತೀರಿ, ವಾಲ್ಯೂಮ್ ಅಷ್ಟೇ ಇರುತ್ತಾ? ಕಾನ್ಸ್ಟಂಟ್ ವಾಲ್ಯೂಮ್ ಇರುತ್ತಾ? Volume is constant, but the pressure is directly proportional to the temperature. If the temperature is increases, ಹೌದಾ, ಸಮ್ಮರಲ್ಲಿ ಟೆಂಪ್ರೇಚರ್ ಜಾಸ್ತಿ ಇತ್ತು ಅಂತಂದ್ರೆ ಅವಾಗ ಪ್ರೆಷರ್ ಏನಾಗತ್ತಾ? ಜಾಸ್ತಿ ಆಗತ್ತಾ. ಅದಕ್ಕೋಸ್ಕರ ಬರ್ಸ್ಟ್ ಆಗ್ತಿರ್ತಾವೆ ನೀವು ಯೂಸ್ ಮಾಡ್ತಕ್ಕಂಥ ವೆಹಿಕಲ್ಸ್ ಟೈರು. ಯಾಕೆ ಆಗ್ತಿರ್ತಾವು? ಅಗೇನ್ there is a physics that is called Gay-Lussac's law. For a given mass of a gas at a constant volume constant ಇರುತ್ತೆ, there is no change in the volume, but the pressure is directly proportional to the absolute temperature. Pressure is directly proportional to the absolute temperature. ಇಲ್ಲಿ ಒಂದು ಫೆನಾಮೆನಾ ಇದೆ, ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರು. Pressure is directly proportional to the temperature. Directly proportional to the temperature, then it is called Gay-Lussac's law. At a constant volume, the pressure is directly proportional to the temperature. This is called Gay-Lussac's law ಅಂತ ಕರಿತೀವಿ. If the pressure is increases, then or if the temperature is increases, the pressure is also increases. If the temperature is decreases, the pressure is also decreases at a constant pressure. This is called Gay-Lussac's law. And the fourth one is that is called Dalton's law of partial pressure. This is also called Avogadro law in your chemistry subject. But in physics we use Dalton's law of partial pressure, or this is also called Avogadro law. And the total pressure exerted by the mixture of non-reacting gases occupying a vessel, that is equal to the sum of the pressures or individual pressures which is each gas exert if it alone occupies the same volume at a given temperature. For the n number of gases, then we use the Dalton's law of partial pressures. That is P is equal to P1 plus P2 plus P3 so on up to Pn. This is called Dalton's law. The total pressure is exerted by the mixture of non-reacting gases. This is not individual pressure. The sum of individual pressure which each gas exert, then it is called Dalton's of pressure or partial pressure. Mathematically it is expressed as P is equal to P1 plus P2 plus P3 so on up to Pn. Here P is the pressure exerted by the mixture and P1, P2, P3 so on up to Pn is the partial pressure of component gases. Hence, the total pressure of a mixture of ideal gases is the sum of partial pressures. This is the law of Dalton's law of partial pressure. This is called Dalton's law of partial pressure. Dalton's law of partial pressure. Okay. Okay. The next concept is that is the assumptions of kinetic theory of gases. In the first video, already I discussed about the behavior of gases, but here I am going to discuss about the concept of assumptions of kinetic theory of gases. Assumptions of kinetic theory of gases. These are also called the postulates of kinetic theory of gases. It consists of large number of tiny particles, that is known as molecules. Gas consists of large number of tiny particles. Tiny means it is a very small. Gas consists of large number of tiny particles. Tiny means it is a very small. It consists of large number of tiny particles. Tiny means it is very small. This is known as molecules. And here, this is the one system. In this system, n number of gas molecules are consist. It consists of large number of small particles. This is known as molecules. And the next assumption is the collisions between the particles and container walls are elastic collisions. There is no loss of kinetic energy during the collision, or there is no force of attraction among the gas particles. When one gas molecule is collide with another gas molecule, there is no change in the momentum of the gas molecule. There is no change in the internal energy of that system. That's why collision among or between the particles and the container walls are elastic collisions. Elastic collision means it is the collision in which both momentum and kinetic energy of the system is constant. There is no loss of kinetic energy during the collision in case of gas molecules collision. There are no forces of attraction among the gas particles. There are no forces of attraction among the gas particles, and all the gas particles of same gas are identical in all the aspects with the same size and mass. All the particles of same gas are identical in all the aspects, like molecules of H2O, molecules of CO2, and molecules of H2O plus CO2. Here in the first diagram, we will consider only the molecules of H2O. In the first diagram, we will consider only the molecules of H2O. ಇಲ್ಲಿ green color ಇರತಕ್ಕಂಥದ್ದು ಏನು H2O molecules. All the particles of same gas are identical in all the aspects. This is very important. And in the second diagram, we consider the molecules of CO2. This is the carbon dioxide. This is carbon dioxide. ಹೌದಾ, ಇಲ್ಲಿ ಆಲ್ ದ ಪಾರ್ಟಿಕಲ್ಸ್ ಆಫ್ ಸೇಮ್ ಗ್ಯಾಸ್ ಇಲ್ಲಿ ಇರ್ತಕ್ಕಂಥದ್ದು ಗ್ರೀನ್ ಕಲರ್ ಇದೆ, ಇದೇನಿದೆ ನಿಮಗೆ ರೆಡ್ ಕಲರ್. ವೆನ್ ಯು ಕಂಬೈನ್ ದೀಸ್ ಟು ಗ್ಯಾಸಸ್, combine the molecules of H2O and CO2, now you get H2O plus CO2, molecules of H2O plus CO2. Easily you can recognize the CO2 and H2O with the same size and mass. All the particles of same gas are identical in all the aspects, and pressure is constant in all the directions. Pressure is constant is all the direction. When you contain, suppose if you consider on a gas cylinder, in that gas cylinder the n number of gas molecules are filled. The pressure inside that gas container is constant in all the direction. In all the direction, this is also very important concept. The pressure is constant in all the direction, and gas particles are always continuous, rapid, or in random motion. Hence they possess the kinetic energy, which is energy of the motion. The temperature of the gas, it depends on the average kinetic energy in it. If the temperature is increases, the kinetic energy of the gas molecule is also increases. Temperature is increases, the kinetic energy of the gas molecule is also increases. This obeys Newton's law of motion. Molecules obeys Newton's laws of motion. These are the postulates of kinetic theory of gases, and these molecules move freely in straight lines obeying Newton's first law, and the total momentum is conserved as usual. The total momentum is conserved as usual. This implies the total kinetic energy is conserved. Hence the collisions are considered to be elastic. There is no loss of kinetic energy during the collision. We can derive the expression for the pressure of a gas based on this assumptions of kinetic theory of gases. That is called the pressure of an ideal gas equation. I will discuss this concept in the next class. Okay.